am Dr. Narsinga, Professor of Physics, Dean Research and Development, Marri Reddy Institute of Technology. So today we want to discuss about the free electron theory, which is the basic theory about magnet materials to which type of properties it will be. It depends on totally in free electron theory. So this free electron theory, it will be different type of free electron theories are there. That means there is a classical free electron theory, that is 3 stages will be there actually. That is initially it will be classical free electron theory, then there will be quantum free electron theory came into picture. So finally it will be block zone theory. Block zone theory or Croning-Penny model, that is effective mass, depends on that block zone theory. It will be all these properties will be depends. So initially it will be classical free electron theory, so which is very useful in to explain all the properties of the materials. It may be magnetic materials or transport properties or dielectric properties, all type of structure, everything will be explained in terms of free electron theory. That free electron theory is 3 stages. The first stage is classical free electron theory. According to classical free electron theory, so it will be the particles, the electron will be moving freely inside the lattice. That means the electron, it may not, it is no boundary so to stop that electron. So it will be inside the crystal, the electron will be freely moving. It's here and there, it will be moved freely. That is according to free electron theory, that is one of the assumption actually. So there is a assumptions will be there. Similarly, there is a silent features, or we can say that's advantages of this classical free electron theory, and there is a limitations and drawbacks, that also we will study here. So that's first one is assumption and silent features. What are the important point to explain according to classical free electron theory? So that assumptions we will discuss. Similarly, in quantum free electron theory also similar, that is what are the assumptions compared to classical free electron theory, what is the different type of assumptions will be there in classic quantum free electron theory. Similarly, there is a advantages, or it will be success of quantum free electron theory, as well as merits. What are the merits of that quantum free electron theory? So then once again, the whatever the theory will be there, it will be positives and negatives. Similarly, the quantum free electron theory also, it has some drawbacks or demerits. So these demerits and drawbacks, it will explain according another extra theory, that is block or zone theory. So these 3 stages will be there in free electron theory. One is classical free electron theory, another one is quantum free electron theory, and third one is block theory. So this block theory will explain to means with the different type of classification of materials. That is another latest block theory will be there. So then, so we will study in a one by one. So what is the free electron theory? So free electron theory means whatever the theories are there in earlier days around 1900. So those theories will explain only the metals, mostly the metals. So in that metals, these free electron theory, what I told earlier, it will be structural, electrical and magnetic as well as thermal properties will explain according to free electron theory. Free electron theory means once again there will be free electron theory means outer cell there will be some electrons. Those electrons we call it as a valence electrons. So major role of these valence electrons are the major role will play to explain all these properties, structure as well as electrical, magnetic and thermal properties. All these properties are depends majorly on electron, valence electron, that is outermost cell. How many electrons are there? Those depends on those electrons, the properties will change. Similarly, that elasticity and coercive force, binding in solids, these all are explained according to this free electron theory. So the behavior of conductors, semiconductor, insulators, these all are will explain according to free electron. Free electron theory, once again we will consider as a 3 theories, that will be second part. So that solids, usually solids in the outermost cell orbit where the valence electrons will be there, those will be determined the properties of the materials. Okay. So that electron theory mostly applicable to solids, both metals and non-metals also. So that's electron theory. So in that electron theory, there is a 3 stages of this free electron theory development. Okay, so to explain the metals. So that first one is classical free electron theory. What is meant by classical free electron theory? We will study here. So similarly, quantum free electron theory. So quantum free electron theory, what is that quantum free electron theory? We will study that one also. Similarly, the Bloch and Zone theory, what it will explain. So usually classical free electron theory means it will, whatever the theory, this theory, it will be applicable all the Newton laws. So Newton laws, wherever the Newton laws follows, that properties will explain according to classical free electron theory. Okay, so that is a classical free electron theory. This is developed by that's a Paul Drude. That's a theory also. We can say it's a Drude theory. He developed around 1900. So that's a very more than 120 years before. So after this discovery, there is a J. Thomson also there. So he also elaborated that theory. So then this theory, they call it as a Drude and Lorentz theory. That is the name of classical free electron theory, or Drude and Lorentz theory. It will be same meaning. Okay. So according to this Drude and Lorentz theory, the free electrons, which are responsible for the electrical conductivity as well as all the properties, those um, free electrons will obey the classical mechanics theory. That means it will be Newton laws it will follow according to this classical free electron theory. Here the distribution of electrons in the means in a lattice, it is the distribution will be follows the Maxwell-Boltzmann distribution. That is Maxwell-Boltzmann distribution. That is a theory of it will be how the electrons will be distributed. It will be in a parallel or it will be in a line like that. There is a another that distribution theories are there. That is Maxwell-Boltzmann distribution. Okay, so that's free electron theory. That is introduction of that one. So then the quantum free electron theory. So after it will be explained only few properties that classical free electrons theory. Some of the properties we cannot explain according to classical free electron theory. Then the quantum free electron theory came into picture. That quantum theory, free electron theory is developed by Sommerfeld in 1928. 1928, Sommerfeld developed some theory which will explain whatever the classical free electron theory demerits are there, those properties they can explain according to free electron theory. So that's this quantum free electron theory is more useful compared to classical free electron theory that is developed by Sommerfeld in 1928. So according to this theory, the free electrons will move with a constant potential, whereas in a classical free electron theory, the electrons will move freely without any boundaries. But here in the free electrons move with a constant potential. Every electron has its own constant potential. So, and it obeys quantum laws, not a classical laws. That is not Newtonian laws. This obeys quantum laws. And the distribution will be not Maxwell-Boltzmann distribution. The distribution in quantum free electron theory, electrons are distributed according to Fermi-Dirac statistics. Fermi-Dirac statistics. So then third theory, we studied this one. So that is a Bloch. The scientist name is a Bloch. So and that name, the theory will be Bloch theory. So he is developed around 1928. So what is the difference between the earlier theories and these theories means? Here, according to this theory, the free electrons move in periodic potential. You can see the first one, classical free electron theory, it will be freely moved without any boundary. Whereas in quantum free electron theory, it will be constant potential. The electrons will be constant potential. Whereas in Bloch theory, it will be periodic potential. So this difference of potential is different in different three theories. Okay. So this theory also known as band theory of solids. So band theory of solids, the name will be band theory of solids or Bloch theorem or zone theorem. It will be similar meaning. So now we will study about what are the first classical free electron theory. What is the assumptions in the classical free electron theory? So usually the assumptions will be the electrons will move freely inside the lattice. Inside the any material, the electrons will move freely because the in each means lattice there is a number of electrons will be there. That number of electrons, all electrons will move freely. all electrons will move freely like a gas molecule. In the gas inside the means house or inside the room, the gas molecules will move throughout the room, in this corner to that corner, so like that. So here also electrons will move like a gas molecules in a container. Okay, so the molecule, like a molecule, electron also moving freely. So in the absence of the field, so if we are not applying any external field, then the energy of that free electrons is depends on the temperature. It is given by 3 by 2 kT. That is one of the means the observations. So that energy is in terms of 3 by 2 kT. In this one, K is the Boltzmann constant, T is the temperature, absolute temperature. So this energy associated with each electron at a particular temperature. So this way we will calculate the energy of that particular electron. So it is related to, once again, the electron is moving. So once the electron is moving means it has a kinetic energy. So if you related to kinetic energy, that equation becomes 3 by 2 kT is equal to half mv square. So mv square, v is nothing but th, that is thermal velocity. Here without any external field, so it will be only temperature is depends. That's why they call it as a thermal velocity. Vth is thermal velocity and K is the Boltzmann constant. This is the energy of the free electron in a classical free electron theory, because here the electrons will move freely without any boundary. So then there is a, what are the assumptions, some more assumptions, that is if the positive ion cores, usually in the atoms what will happen, there is a electron, so neutron will be there in center, the electron cloud will be surrounded. So this electron core and positive ion core, this positive ion will be fixed one, that free electrons move randomly and there will be colloidal also. Okay, so this collide is nothing but there won't be energy transfer, it will be elastic collision. Okay, the collisions are elastic collisions, so therefore there will be electric conduction is due to free electron movement. So once the electron is moving, then the current will be flowing. So once the current flow means it will be like a conduction will be coming out. So that's one assumption. What the assumption is, there will be positive ion core will be there, that is a fixed position, but electron is freely moving, it will be collide with the positive ion, but that collision is elastic collision. So they assume like that. Okay. Similarly, the second one is the electron velocities in metals, it will be obey Maxwell distribution. That means the distribution electron, here one electron, here another electron. So there will be some rule to make the electron will be, the positions will be fixed. So that we call it as a Maxwell-Boltzmann distribution. That is a Maxwell-Boltzmann distribution. So it will be, electrons will be distributed according to that. So here another assumption, important assumption is there is a constant potential field. So we have to apply the constant potential, means the electrons will move constant potential field. Okay. So hence the potential energy of the electron is constant. So it is moving with constant potential means it will be moving only one direction like that. So that's why the potential energy becomes constant. So when the electric field is applied to a metal, free electrons are accelerated in the direction. So that means usually the electron will move opposite direction of current direction. Current direction will be in the right side, the left side the electrons will move. So that's all we know that. Okay. So that's electrons will move opposite direction of the applied electric field. So this whatever the gaining of that energy, after that gaining of this electric field, the electron will move fast. So that electron thing we can calculate in terms of velocity. So that we call it as a drift velocity. So there is a two types of electron movement or hole movement, that is a drift and diffusion. It will come in a semiconductor usually. So drift means we have to apply some external applied field, whereas diffusion means there will be no external field, only the carrier concentration difference. If the one side it will be more concentration, other side is less concentration. So the more concentration electrons will move towards the less concentration of electrons. That will call it as a diffusion process. Here it will be drift process because we are applying the electric field. Electric field to that metal. So then electrons will gain the some energy, then velocity. That velocity we call it as a drift velocity. It is represented by Vd. So then those are the assumptions. Assumption is it will move freely without any boundary, and it will be collide with a neutron or a center core one. So it will be elastic collisions. Then it will be distributed according to Maxwell-Boltzmann distribution, and it is the electrons will move opposite to the electric field. So these are the silent means assumptions of the free electron theory. So with those observations, so there is a what are the success of this free electron theory? So the success of free electron theory depends on there is a it verifies the Ohm's law. Ohm's law, we all know that V is equal to IR. So this formula will be means follows the metals, because if you apply the more voltage, so you will get the more current. That means the resistance will be decreased. So this range, this type of equation, it follows the metals. So that means it verifies Ohm's law. That is one advantage of this free electron theory. And it will explain electrical and thermal conductivities of metals. This electrical and thermal conductivities of metals, it will explain, and it derives Weidmann-French law. This is also related to electrical as well as there is some equation if it is related to K by sigma T. So here K is the thermal conductivity, sigma is the electrical conductivity. It depends on the temperature once again. So this they call it as a Weidmann-French law. So it follows the thermal as well as electrical conductivities. There is a equation of like this. There's a Weidmann-French law. This is the Ohm's law. Okay. Then it will explain optical properties of metals also. It will explain electrical and thermal conductivity of the metals as well as optical properties of the metals. So these are the advantages of classical free electron theory. Advantages of classical free electron theory. First, earlier one, it will be assumptions. What some assumptions, then they made some theory. According to that theory, these are the success or advantages of that theory. So then there is a once again it will be drawbacks. So using that classical free electron theory, some of the properties may not be explained. So that is we call it as a demerits or limitations or drawbacks. So that will be same meaning. Okay, limitations or drawbacks or demerits. So what is the demerits? How it will fail, or what are the properties it will fail to explain the according to classical free electron theory? The first one is the electrical conductivity of semiconductors and insulators. Because the classical free electron theory, it will explain the electrical conductivity and thermal conductivity of metals, but it cannot explain semiconductors how it will be. Similarly, insulators how it will be. So it will explain only metals only. So these are the because there is no theory of these two, so that's why there is a drawback of classical free electron theory. Similarly, the temperature variation of electrical conductivity at low temperature. Usually at particular temperature, what is the conductivity, it will explain, but temperature dependent, it won't explain. Usually it will be explained at room temperature, but it's temperature, low temperature or high temperature, we cannot explain the electrical conductivity usually at low temperatures. Okay. So that is also one of the drawback of classical free electron theory. Similarly, the concept of specific heat of metals. Concept of specific heat of metals also we cannot explain according to classical free electron theory. Usually, why the quantum mechanics came into picture means these are the some of the properties we cannot explain. So that's why the quantum mechanics came into picture. Similarly, here the classical free electron theory cannot explain some of the properties of these properties. So then the quantum free electron theory came into picture. Okay. So then the mean free path of the electrons. So that means the stability of the electron also we cannot explain according to classical free electron theory. So another one is like photoelectric effect. So photoelectric effect means if the light incident on the metal surface, the electrons will be ejected. So those type of properties we cannot explain according to classical free electron theory. Similarly, Compton effect. Compton effect also they cannot explain according to this classical free electron theory. Similarly, another one is black body radiation. Black body radiation also it cannot explain according to classical free electron theory. Usually, if black body means it absorbs all types of radiations and it will emit all types of radiations. Okay, if you heat up that material. Usually, if you draw the curve between wavelength versus energy. So, if you are a metal heated up to 2000, then you will get like this. So, that means there is a maximum wavelength at particular temperature. So, this maximum temperature is decreased towards lower wavelength side. So, that is if it is 1500 degrees centigrade, this one is 1200 degrees centigrade, it will be higher value, 1500 will be lower wavelength side. So, that means it is continuously, if you increase the temperature, it will decrease towards lower wavelength side. But what the classical free electron theory will tell, if the wavelength is decreased, it continuous increase. This is the Rayleigh-Jeans law tells. The Rayleigh-Jeans law is according to classical free electron theory. That theory tells like this curve. But if you are any thermal means experiment like our home, there is a burner means in kitchen. So if you heat up that burner, then what will happen? Initially it will be red or orange color. If go on increasing the volume of the gas, then it will go to different colors. You can observe that one. So it will be blue color also. It will come blue to white. So its white will be very high temperature. But only white will come? No, there will be in other side one, there is a different colors. So that different colors will explain this curve usually. So the one color will be maximum, then there will be, so one curve will be maximum. So then that at particular point it will be maximum intensity. So that means it may be yellow color or blue color, but remaining colors also there. So this part we cannot explain according to classical free electron theory. But quantum free electron theory it will explain, that we will see in the next part. So here usually classical free electron theory it will show like this. That is a black body radiation case. Okay. So then there will be the temperature dependence of paramagnetic. So if it is a paramagnetic or ferromagnetic, these type of properties we cannot explain according to free electron theory. So these are the drawbacks of free electron theory. So next one is, so these drawbacks, if you want to escape from the drawbacks, or if you want to the drawbacks useful to the means we can explain those properties, then the another theory is required. That theory came into picture around 1928. That classical free electron theory is 1900. So this quantum free electron theory, after 28 years, this Sommerfeld he developed some theory that is called it as a quantum free electron theory. So it will be overcome most of the drawbacks of classical free electron theory. So this they will explain according to, that means the energy or velocity or particles or electrons inside the lattice, it will be according to Fermi-Dirac statistics. So this how the electrons will be arranged in that lattice, it will tells according to these statistics. That one is Boltzmann statistics, this one is Fermi-Dirac statistics. So whereas in classical it will be Maxwell-Boltzmann statistics. So this theory will be developed applying the principles of quantum mechanics, whereas earlier theory, that is Drude theory, it will be Drude and Lorentz theory. It will explain most of the properties to apply the principles of classical mechanics. Here it will be quantum mechanics. So in quantum mechanics, there is once again there is some observation. Whatever the theory you are making, so you need some assumptions. In quantum free electron theory, that's assumptions will be the electrons here also, the valence electrons will move freely, but at a constant potential within the boundaries. If the lattice is like this, that means the material is like this. So the electrons will move is a constant potential within this boundary. So it will not go to one place to another place. So it will be inside the boundary, the electrons will move with a constant potential. Okay. So it won't escape from that boundary condition. Okay. So that means it is nothing but trapped in a one potential well, because the constant potential is there. It is not going outside, so it will be, electron will be trapped inside the lattice. So the distribution of electrons in various allowed energy levels, it will be according to uh, Pauli exclusion principle. Pauli exclusion principle tells that in each cell it will be only two electrons. One will be up, another one will be down, like that. So that is energy levels will be depends on the electron, how it will be. So then the attraction between the free electrons and lattice ions, so there will be repulsion also there. So usually the repulsion is ignored with a different electron to electron collision, like that. Okay, the repulsion means there is a, if usually the electron negative negative, it will be repulsion will come, like a magnetic. If the past south pole, it will be repel, south north, it will be attract. Here also they ignored this repulsion energy or repulsion force. They ignored this repulsion force in a quantum free electron theory. Okay, so this assumptions, these are the assumptions of quantum free electron theory. So with these assumptions and some more few assumptions also there, that will be according to distribution of energy, that is according to Fermi-Dirac statistics, and these energy values of free electrons are quantized. That means if the particle is inside the one well or inside the lattice, so that means the potential energy will be constant. So that means the energy values will be, it may not be continuous increase or continuous decrease. It will be constant potential energies will be there for each electron. So that will be, it will be, they call it as a quantized free electron theories. It may not be zero, it will be in a number, that means integer numbers, 1, 2, 3, 4, 5, like that. So the possible energy values of electrons, so according to, we calculated according to Schrodinger wave equation, this Schrodinger time independent wave equation. So we will apply to measure the possible energy values, and there they use some problem, that is a one dimensional box, the one dimensional potential box, say, they will say like that. So in that potential box, the electron will move freely, that means along the x-axis. Then the energy levels will be follows this equation. So here En is the number of the levels. If n is equal to 1, so then this one will be h square by 8ml square. M is the mass of the electron, L is the length of the box. If the length of the box x or length of the box 1 angstrom, so they will use like that. So that is 8ml square. N is the order, first order energy or second order, like that n will decide. The n is a integer 1, 2, 3. So here also that's n is not 0. That means if n is equal to 0, the energy will be, the electron will be in a 0 position. That means without any energy. That means it will be at a particular position, it will be constant. That means it won't move. But in the, we saw there, we assume that the electron will move freely along the one path, that is a surrounded path, neutron surrounded by neutron, that is a electron cloud. It continuous moving. So continuous moving means the energy may not be 0. It is quantized. It may be depends on the n is equal to 1, 2, 3. So that's a free electron energy for one dimensional box. Okay, that is assumptions of quantum free electron theory. So with those assumptions, what are the advantages or what are the merits of quantum free electron theory? There is a different merits, means where the classical free electron theory is failed. So the quantum free electron theory, it will explain those properties, like electrical and thermal conductivity of metals. So the earlier that the electrical and thermal conductivity of metals, that is also explained, but with the different temperatures, they cannot explain according to that. Okay. So here electrical and thermal conductivity of metals, they will explain according to free electron theory. Then the thermionic phenomena means if the heat of the material, then the electrons will be ejected. That is a thermionic emission. Okay. So in that phenomena also, we cannot explain according to classical free electron theory. So then the quantum free electron theory came into picture and it will explain very well. Similarly, the temperature dependence of the conductivity of metals. Usually, the conductivity of metals, it will be at room temperature. Well, very small values are there, metals. It's semiconductor and insulator, it will be high values. But with temperature, if it is a room temperature here, T is equal to 300 degrees and 300 K. So, if it is low temperature, how it will behave? It behave like it will constantly, it is decreasing slowly at a lower temperature side. Okay, so this phenomena or this property, that means the conductivity of the metal with decreasing temperature, it will decrease. So this phenomenon we cannot explain according to classical free electron theory. So in quantum free electron theory, this phenomena, that means the behavior of this temperature behavior, it will explain very well. So and there is another point is specific heat of metals. So metals specific heat, that is uh, specific heat of the metals, that is nothing but thermal energy only, releasing of thermal energy. Heat capacity they will call it as a, okay, heat capacity. So usually the metals, it will in the actual the theory quantum free electron theory, why it came into picture means, usually the normal free electron, if it is a metal, it will be the heat capacity or specific heat versus temperature, it will follow like this constant. But some metals or most of the metals, they will be not following it same path. This is a theory one, earlier theory, classical free electron theory. This is experimental one. This experimental one, they will explain according to quantum free electron theory. So that's why this specific heat will explain according to quantum free electron theory, it will be very well. Similarly, the magnetic susceptibility, that means magnetic properties of the metals, we cannot explain according to classical free electron theory, but here in quantum free electron theory, we can explain magnetic susceptibility. Okay. Similarly, the photoelectric effect, there is a disadvantage of classical free electron theory, but merits or advantage of quantum free electron theory is photoelectric effect, it will explain, Compton effect, it will explain, and black body radiation also, it explain according to quantum free electron theory. And this it will give you the mathematical expression for the thermal conductivity. So usually the French law, so if there is a thermal energy and electrical energy, electrical conductivity, so there is a formula will follows the mathematical expression with correct values. So that's also one of the merit of this quantum free electron theory. And if this theory also, there is a some demerits are there, demerits of this quantum free electron theory. So those demerits, that means some of the properties, it also, the quantum free electron theory also not explained very well. So those what are those things? So the demerits of the quantum free electron theory, so it will be only that it is unable to explain some of the crystals conductivity, it cannot explain according to quantum free electron theory. That means some of the crystals, they show some transitions. So the conductivity will be like this. So these type of properties, they cannot explain according to quantum free electron theory. So that's why that's certain crystals, some of the crystals, the conductivity or metallic property is nothing but conductivity. So they cannot explain according to quantum free electron theory. So we require some other theory. So it will unable to explain the atomic arrays in metallic crystals. Okay. So why it will be in usually we will say if it is any crystalline one, so it will be the atoms will be arranged in systematic way. So this thing also we cannot explain according to quantum free electron theory. Similarly, it failed to distinguish, there's a major one, this metal, semiconductor and insulator. So we cannot explain according to quantum free electron theory or classical free electron theory. So we cannot distinguish these three materials. There is metals, how it behaves, semiconductor, what is that, insulator, what is that. So usually the classical free electron theory, quantum free electron theory, mostly it will be for metals. So the requirement is some other theory required to explain different type of materials. Okay. And it also fails to explain the positive value of Hall coefficient. Hall coefficient also, there is a one of the experiment, it will explain, it will define which type of material it will be, N type or P type. So those type of P type material we cannot explain according to Hall coefficient using quantum free electron theory. Okay. So this theory to tells only two electrons are present in the Fermi level and they are responsible for conduction, which is not true. So only two electrons, it's not possible. The two electrons is only one cell it will be. So there will be number of free electrons will be there. So that means it may be more than two also there. Okay. So that type of assumption is not correct, and this it is not explained that type of uh, Fermi level. Okay. So that is demerit of quantum free electron theory. So these are the three theories. One is classical free electron theory, another one is quantum free electron theory, and there is a third one is block theory. So we will go for next class that one. So these two theories we have to explain what are the assumptions and what are the disadvantages, and these two we have to study with the free electron theory as well as quantum free electron theory. So thank you.